Hi, in the last video I explained to you what indices is about, okay, and the laws of indices. Right now I'll solve some examples to show you the application of these laws of indices. The first example will be to find the value of 16 raised to the power 1 over 8. Okay, this is easy. From the fractional law, which this should give us 16 raised to the power 1 over 8 would be equals to the 8th root of 16. 8th root of 16 all raised to the power 1. Okay, now 16 could be seen as 2 raised to the power 4. So instead of writing it in that form, you can also write it in this form: 2 raised to the power 4 all raised to the power 1 over 8. Multiply this would be 2 raised to the power 4 times 1 over 8. 1 over 8. Doing that would yield 2 raised to the power 1 over 2. Then 2 raised to the power 1 over 2 would mean the square root of 2. It's as easy as that. Yes. So the second example would be to evaluate 81 raised to the power 3 over 4 minus 27 raised to the power 1 over 3 all over 3 times 2 raised to the power 3. Okay, now from the laws of indices, we have fractional power. 3 over 4 would be, we have the root sign, the denominator, which is 4, would be behind here, and then 3, which is the numerator would be a power. So that would be 4th root of 81 all raised to the power 3 minus, the same thing applies to this, cube root of 27 all raised to the power 1 all over 3 times 8. Okay, because 2 raised to the power 3 will be 8. Okay, so that would be 4th root of 81 is 3. You all know that, minus cube root of 27 is 3. So that would yield 3 raised to the power 3 minus 3 all over 3 times 8, which is 24. So that would be equal to 3 raised to the power 3 is 27 minus 3 is 24 over 24, and that would give us a result of 1. I hope you understand this. Now we're going next to equation involving indices. This can be solved using a first method called the expression. An example will be 3 raised to the power x equals to 27. Now we are going to express 27 in the base of 3. Since we have 3 raised to the power x, 27, if 27 can be expressed to a base of 3, then we express 27 to a base of 3 so that we can now juxtapose. So in this case, we have 3 raised to the power x to be equals to 27 to a base of 3 will be 3 raised to the power 3. Now since 3 raised to the power x is equal to 3 raised to the power 2, there's another way of saying this. You could say is, since 3 raised to the power x is the same thing as 3 raised to the power 2, that will imply that x is equals to 2, as the bases are equal. Another example will be x squared equal to 4. Now we'll express 4 in the power of 2. This is easy. X squared equals to 2 raised to the power 2. Since x raised to the power 2 is the same thing as 2 raised to the power 2, that will imply that x is equal to 2. Since the powers are equal, equate the base. Since the bases are equal, equate the power. This is called expression. Now, the second method will be the reverse process. This will be an example of a reverse process now. Like the x squared equals to 4. In this case, we'll take the square root of both sides. This is called the reverse process. We're assuming that we can take the square. If we take the square root of both sides, the squared from the x would go, and this will be taking the square root. This will be so the square cancels the square root. This is because the square root sign means a power of 1 over 2. So when we have x squared, square root of x squared, this can also mean x squared all raised to the power 1 over 2. 2 times 1 over 2 will give us 1. So that is x raised to the power 1, which is the same thing as x. So that is why square root of x squared equals to square root of 4 will give us x equals to, square root of 4 will be 2, So that will give us giving us x equals to 2. And then another example would be square root of x equals to 16. The reverse process. The easiest way to take away this square root sign will be to square both sides, since 2 times 1 over 2 would give us 1. So you take the square of both sides. So that will be x, square root of x all square equals to 16 all square. Like I explained earlier, the square can cancel out the square root sign. So that will be x to be equal to 16 square, and 16 square is 256. 256. The third method will be the power reciprocal multiplication. Power reciprocal multiplication. In this case, if you have x squared to be equal to 4, this would yield, to remove, the basic thing to do here is the fact that we want to find x. And so the thing to do is to try and reduce the square in the x to 1. So the basic thing to do here, if we are to use the power reciprocal multiplication, will be to multiply the power of x by its reciprocal. The reciprocal of 2 is 1 over 2. So you multiply, you say 2 times 1 over 2. That will be to reduce the power of x to 1. So because we have 4 on the other side, you have to do the same thing to balance the equation. To the right hand side, you have 1, then multiply by 1 over 2. So this will yield x to be equal to 4 raised to power 1 over 2, and that will be equal to x square root of 4, and so that would be 2. I hope you understand the basic interpretation and the laws of indices from these examples and this explanation. Thank you.